there is no universal acceptance for that. But at engineering level, some better attempt has been made. People have done that these four categories are inadequate to capture the nature of engineering. And we have learned the hard way. It took me more than 10 years to fight that particular issue in my department. Because whatever we were doing in our department, somebody said this is not something that should be pursued in a place like IAS. That's how it started. Then we tried to understand it. Then what happened, we found fortunately a good piece of work by one Professor Vincenti. He is one of the well-known aeronautics professor from Stanford. And he's still active. He's 102 years. He got his highest aeronautics award at the age of 100. Okay. There is a special medal for that. He has only left Stanford University and went to live at some other place, but he still got his highest award at the age of 100. He said, he wrote a nice book, if you want you can read. What do engineers do and how do they do it? Okay, he took cases from aeronautics discipline, obviously they are there. And then he tried to say what categories of knowledge do you want are there specific to engineering. And he only looked at from engineering, he didn't bother to look at physics and so on. So from his side, he identified 6 categories of knowledge. These are involved in any engineering discipline. And he presented with our specific case study, historic case studies, how it is done. And then if you compare those 6 categories with the 4 categories that we talked about, there are 2 categories that are common. So we can keep that aside. We don't have to repeat that. But we still find 4 additional categories of knowledge. And then what we found, if I remove these 4 categories, I am removing engineering from engineering. Simple. And they are not addressed at all by any of the engineering programs. That means we have officially removed engineering from engineering programs. That's what it is. For example, for me the most important one, do you do any engineering activity in any branch where you do not start with specifications? You don't, right? But where do you teach so-called criteria and specifications in any discipline? At least electronics I am familiar with, nobody talks about it. And when you ask the students, what should be the power supply? Okay, with some difficulty somebody will say for digital circuits, he may say 5 volts. We have people who said 220 volts also can be applied for digital circuits. And then you won't ask the next question.
Remove that base band. Now switch off and switch on.
No, we can use if I can use.
Yes, sir, you can use.
I can use this.
Escape. No, let's escape. No, let's escape. Because PowerPoint would have gone into the
Idle mode.
There is nothing in engineering activity that doesn't start with some specifications, right? But we don't sensitize what is the importance of specifications to students at all. For example, we teach them, again I give the electronics example, how do you design a power supply? Okay, I want to design a power supply with 5 volts. What is the, what kind of regulation? Pardon?
it works now.
Okay.
So many times that's the reason. In computer science we all shut down. Again reboot it work.
Or otherwise give it a kick. And that is Okay, we'll come back to this. The, so the engineering wise, if you want to restore engineering to engineering disciplines, unless you, the premise is, unless you bring in these categories of knowledge back into the program in some way, even the way you design your courses and offer the courses, you are not training somebody as an engineer. He has some engineering science knowledge. He is not usable in any organization. Okay? So the idea is how do you restore that engineering back to engineering, and by identifying the categories of engineering knowledge on which one has to focus on. And that is what is given by Professor Vincent. So we call it Vincenti categories of knowledge. Because it's not mine, it is Vincenti categories. And it has been critiqued, but it is also not extensively followed except for a few places. So the whole thing, yesterday we spent some time on what is engineering. Because engineering itself we don't have clarity. Yesterday we found everyone has uh, their own view or non-view also. People consider that it's not even necessary to ask that question. Uh, so what happens is engineering and science, yes, they're closely related. They're dependent on one another, but they are not the same. And one is not a part of the other. At least, if you accept that, then you also need to understand who is a good engineer. For example, if I ask, uh, can you name 10 greatest engineers in the world? Hmm? Yeah, that's all. One name from India we can get. Yes. Other than that, can be in different branches, can be identify who are the great engineers. We don't remember, we don't associate, we don't have even a view of who is a great engineer. Okay? Anyway, we are not going to get into that. Fortunately for us, the POs that have been defined by NBA, they characterize, at least to some extent, who has to be, who can be considered an engineer. At least POs are given. Though I would, if you ask me, I would like to slightly rewrite them, but doesn't matter. But somebody has given. At least it is not zero knowledge on that. We will. The problem is we already can see the problem where it starts. For example, this is one of the definitions. Engineering refers to the practice of organizing the design, construction, and operation of any artifice which transforms the physical world around us to meet some recognized need. That is Rogers, which is, in my opinion, is a proper definition of engineering. But whereas, look at the debate, which is the highest defining body, what does it do? It says engineering is a profession in which knowledge of mathematical and numerical sciences gained by study, experience, and practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. They can reverse that. So again, even when we come to professional organizations like IEEE is slightly better. But if you look at these organizations, they first insist on the process part. Unless you know science, you are not an engineer. They will not say who is a good engineer or what is engineering, and then to achieve that you should know science. Yes, that we agree. So the process is put first rather than part of the process. That is not a complete part. If you know only science, you can't do engineering. You require something more for engineering. And that is not stated there. Okay. So here, this is my standard graphic that I use. If you call engineering is applied science, you have already killed it. Because if you add an adjective, it becomes a subset of science, right? And it's applied. So applied science is a part of science. That means there is nothing in engineering that is outside science. It gives you that view. Obviously, when you ask people, yes, they will say, I would rather like to represent engineering and science, something like this. There is a lot of intersection, but there is something outside that intersection as well in engineering. If I ignore all this, let me use this. If I ignore all this part, I'm throwing engineering out, right? What is that part, you can ask. You can find an answer to that. We may differ in terms of details. But there is something outside this. And if you want this applied science, you can make it intersection more if you want. It's okay. But still there is something outside that intersection. And
Engineering is not a subset of science because there is no engineering without science.
Yeah, that we agree. No, but engineering existed much before any science came. The word science itself is formally came into usage in 17th century. But engineers have been there, engineering activities have been there for the past 5,000 years. They may have some knowledge which is intuitive, which is scientific in nature. That way, like you take astronomy, how sun moves and things like that, they've observed. But it's not any formal science that they went through. Observations, yes. But there is a lot of interdependency on science with science and engineering. You cannot have science without engineering. That they don't want to acknowledge. Because how do you measure anything without somebody building an instrument for you? And building an instrument is always engineering, right? And it has gone to, it is not merely a definitional issue, it is a political issue. Political issue in the sense, many places in the world, in India for example, if you talk about space program, designing a rocket, designing a satellite, sending it up, is it an engineering activity or a science activity, pure science activity? Engineering activity, right? How does it get reported? If it is successful, it is a triumph of Indian science. If it fails, failure of Indian technology.
Basically, because the space technology was headed way initially.
No, sir. It's ingrained so much. We are self-defeatist in that point of view. Everywhere you keep talking about triumph of Indian science when you talk about space program. And you know when you have Academy of Sciences, National Academy of Sciences, and so on. When somebody said that should there be an Academy of Engineering, you know what the answer is given? If and when engineering grows to that kind of stage, then we will talk about having such a thing. Who designed all the goddamn dams and structures in India? And what? So the whole language that we speak, both in press or in media and otherwise in decision making, it's all what do you call, not willing to recognize that engineering is a bona fide activity and it is something somewhat different in terms of its goals from science that is not accepted. Even today, space program, if you talk about, it is all science. Okay, we will not go through the formal definitions like this. This is what I am talking about. Vincenti, please, if you. The book is not available electronically. It can only physical copy possibly you can get. Now he talks about these 6 categories of knowledge: fundamental design concepts, criteria and specifications, theoretical tools, quantitative data, practical constraints, and design instrumentalities. Okay. In this, we look at theoretical tools. And quantitative data we can remove because you can associate with them theoretical things as procedural knowledge or conceptual knowledge. And right, the quantitative data can be talked about as factual information. Okay? The prescriptive or descriptive data can be considered. So the other four, if you do not address them, then you are missing something about engineering. That is the basic idea. Now, there is, I don't know whether you have heard about emergent property. Okay? If you talk about that, that means, take an example like von Neumann's stored computer thing. What is the principle that he has brought in? If you create a store a set of instructions, whatever it is. If you have a memory in which you put instructions, and by operating on that, you can create functionality. You can do functions. But with that one particular concept, the whole field of computer science came into existence, right? But can it come directly from science? What science does it come to? Somewhere there is a particular jump that has taken place. And he has come with that particular concept. And once that concept is there, then you can explore associative science. And then keep improving things. So the concept like this has emerged independent of the underlying science. The underlying science existed even much before. But like as I said, I was giving examples. James Watt's steam engine got created 100 years before the word thermodynamics was uttered. Okay, Wright brothers aircraft was flown 50 years before aerodynamics word has come into existence. And it is true for so many devices, so many products, completely different. And that is what you call as fundamental design concepts. These concepts have come independent of, it could have come even earlier. But only after it came, the new devices, new technologies, everything is kind of got developed. And with the help of understanding underlying science. Yes. Even today, for all chemical processes, if you want to optimize any chemical process that you talk about, doesn't come through understanding the science below that. Optimization is done by brute force, by keep on experimenting, collecting huge amount of data with all kinds of parameters continuously changing, and collecting the data, and then coming out with the best possible combination of parameters. And once that is done, then you can have all the science explaining that. Yesterday I was reading an example in an aircraft engine. Somewhere after Second World War, there were parts, there were problems occurring, stalling occurring for planes and so on. Then they said the static vane and the other moving vane in the aircraft engine. The static vane angle, if it can be changed, then you can have a better performance with it. That engineer has come out with that particular concept. After that, it has become standard, and any amount of theoretical work is done to justify or improve that particular concept. So there is always a kind of emergent property that comes that you can come up with, and that part one has to understand. So that is what we call as a fundamental design concept. Coming to criteria and specifications, I have already been explaining. You don't have anything in engineering without criteria and specification. You cannot send somebody as an engineer if he doesn't have appreciation of what a specification means. For example, if you want to say power supply with 0.01% regulation, you want to say, or what is the 1% regulation? What is the difference between a 1% regulated power supply and 0.01% regulated power supply? If you don't explain, it means the same thing. You give the power supply to the student. Some 4 diodes and 1 capacitor is the power supply. And fact that 0.01% power supply costs 100 times more than 1% power supply. That he will not appreciate unless you sensitize him. And if you cannot talk in terms of numbers, the industry cannot function. They will not like. If you are able to sensitize him to criteria specification, then he will become a better employer, first of all. And then you have practical constraints. You do not have everything that you want to design something, either information or the tools that you will not have. I'm sure day to day you will have. Somebody will say, no, that is not available in our store, and it is too expensive to buy, or in a given time something is not available. What do I do? So people run around and find out the way of solving with those constraints with what is available. Right? That is part of a day-to-day engineering activity anywhere in the world, in any discipline. What do I do? So, but the nature of this particular knowledge is very different. It is not as abstract, as streamlined as the other type. Then there is another thing called design instrumentality, which is a word that is again coined by that. When a group of people are working, there is certain, for it to be effective, they have to follow their own self-defined some norms. That is, we must share information in such and such a time. We want to take a top-down approach to designing something. We need to take design walkthroughs, which is a common thing in the computer science discipline now, and a whole bunch of things that simple rules and the procedures that we follow to solve the problems of designing something big. And those are called design instrumentalities. But among all these things, if you look at for me, the criteria and specifications come at the top. First of all, that should be introduced. Somehow the students will have to be sensitized to that. Okay? So these 4 categories we are talking about. Here I have some examples for each one of them. Fundamental design concepts. A device can perform variety tasks by incorporating memory into that. That is the one nano's principle. Or a device that has 2 well-defined states can be used as a memory device. That's how still not all memories are designed as of today. And stepping movement can be created through interaction between 2 salient magnetic fields. Once then the step motors and all the types of motors that are presently used in precision automation and all that come after that. An airfoil by virtue of its shape, in particular its sharp trailing edge, generates lift and incline at an angular attack, an angle to the airstream. Right? That is a standard thing, but until somebody has come out with practically identified, airplanes did not fly. They may not have stated like that, but that is what, when it is produced, yes, then all the aircraft came into existence. So criteria and specifications have said enough. We don't have to look at that. Practical constraints, all kinds of constraints. The nature of knowledge is somewhat different compared to the other ones. Design instrumentalities, I have explained, I gave examples also. Top-down approach, phasing of development of a product. For example, there is a lot of research that has gone in where how do you optimize or minimize the amount of time to be taken to develop a product. There is a lot of mathematics to develop, but the goal is how do I, that's a part, what you call as a design instrument. How do I plan some activities will have to be sequential, some activities can be parallel. How do I make a combination of this? to design my product in the minimum amount of time. So all these are design instrumentalities. Okay. So these are the four categories. Uh, and if you can somehow incorporate that into offering your course, you don't have to change the uh, content completely. But if you pay attention, you will be able to make him a better engineer with your courses. That's all I would say. Okay, we have to quickly move forward. And this information for what you call engineering science or science courses, where we are talking about four categories of knowledge and six categories, six cognitive levels, you can put them in the form of a table. Simple table. Nothing big deal about it. Graphically, you can create that. Any activity that you talk about, if you, let's say, course outcome, a given course outcome can be located in one of these sites, depending on where you are. Okay, you can do that, and I will not spend more time on that. Whereas in if you talk about revised blue Vincenti taxonomy table, now we have additional four categories of knowledge. We add that as well. So it becomes a 6 by 8 thing. So you use this extended taxonomy table for engineering courses. As we said, there are hardly 6 or 7 engineering courses in any engineering program. Rest of them are all science courses, science and engineering science courses. Truly engineering courses are only in any branch. Maybe I would say 5 to 8. That is the range that you have. Okay, so all your COs and all your assessment, everything can be located in the corresponding one. And why do we want this? We want, ideally, if you talk about CO here, which is located in this cell, okay, and it's located in that cell, then AI, uh, assessment items. Assessment items should also belong to that cell. And IA is instruction activity. What I do in the classroom also should fall under this head, under this head. That is what we call perfect alignment. So am I achieving alignment among my instruction, assessment and outcomes? So I can always make use of this table as a tool just to make sure for myself. It is not a very complex or phenomenal tool. It's a simple graphic tool to make sure that am I doing it right. Sometimes we have to do like this. What happens? Your CO is here. Your CO is here, and then all my assessment as well as instruction activity only falls in these three. I explained, I asked them to remember, I solved some problems, but my CO is in the analysis category. That means there is no alignment between outcomes and my instructional activities and assessment. I can have fantastic CO, and I ask questions like define this, define that, state this. Obviously, you are not training him for that particular role. There is no alignment between outcomes and this. So you can use this as a kind of a tool for that. Okay, that is about the taxonomy. Already we shifted quite a bit. We will go to the other, if you have any questions. Change. What happened? This doesn't work. remove this slide, close this slide, and take the other one. Now we come to really the crux of, sorry I'm rushing a little bit, crux of that, how do we write outcomes? We have looked at already program outcomes which are given by NBA. Now we have to write for each branch separately program specific outcomes, which are 2 to 4 in number, and then we have to write outcomes for each course. And the number of outcomes that you write will depend on the number of credits associated with that. There is no fixed rule that you have to write this many type number of outcomes. Okay? Okay. No, this is it. Yes. Okay, this is what we will be seeing. So PSOs represent what the student should be able to do at the time of graduation from a specific program. Means from civil engineering, at the end of 4 years as a civil engineer, what is it that you will be able to do? Can I capture them? And you have to capture them through maximum 2 to 4 statements. And when I put and also we have shown you a graphic where your curriculum has to be designed from the top. That is POs and PSOs you write, and from there the courses have to emerge. Though we may be doing the reverse process, but ideally, when you are at least redesigning the curriculum, you should start from the top. That means when you start from the top, you have to write your statements appropriately. You should spend some time in terms of writing those statements appropriately. Okay, one way to do is, every branch has some streams, right? If you take mechanical, you talk about design, manufacture, thermal. So 3 streams. And you can write maybe one statement for each one to imply the courses that you want to offer in the team. That is one way. And if you consider one area is very important, you can have 2 statements. Whereas if you take EEE, you have electronics and electric. You can have, again, a set of statements, 2 statements for electrical and 2 statements for electronics. Take EC, again you have 2 streams, communication and electronics. You can have either 2 or 3 or 4 statements. We will show you some examples. Whereas civil only has a bit of issue. It has as many as 5 streams, and you cannot have 5 PSOs. So obviously each program will have to compromise a little bit and come with 4 statements. Okay? And how do we write that? It also should have some structure.
Is there any specific reason we have 4?
That is their choice. No, they consider what we call your geotechnical engineering, structures, hydraulics, environment, transportation, all the 5 streams that is there. They have taken all that under their wings. And if they want to give, they have to write, but unfortunately they have to write only 4 statements. Okay. That is the peculiarity of that. And PSO can also capture, if there is, you can also differentiate your program through PSO statements. For example, just now at lunchtime, I went to EC department, looked at that, they have got some special equipment, which other colleges may not have. And if you think that you want to attract your students and say that I am training people even for that. So I can have a kind of a PSO written like that. I am differentiating my ECE program through those that because of the availability of either faculty or resources that I can offer a very specific type of program. For example, there are hardly any institutes who specialize in, let us say, high frequency communication, high frequency area, because the equipment is very expensive and not many specialists available. I know on Madurai Tyagaraja College, They have had the tradition of having that very strong discipline. They have excellent faculty, excellent facilities, expensive facilities. One Pune Engineering College had. They somehow long back they acquired a phenomenal amount of equipment, and I don't know whether they're continuing to utilize it effectively. So you can be, depending on what you have, both human and physical resources, you can have your specialized, you can differentiate your, all core courses need not be identical for all BE programs. Only that happens because you unfortunately come under one university as an affiliate. If you are an autonomous thing, there is no need. You can differentiate your undergraduate program slightly. See, most of the courses in any program, take mechanical or civil, they define by themselves. Fluid mechanics, nobody asks you whether it should be there or not, right? Simple. Strength of material, should it be there or not? Nobody questions. Should I have 3 courses in mathematics? Nobody questions. So most of the curriculum are automatically almost defines by itself. It is only through few courses that you can differentiate. Okay? And here, how do we write? We can use multiple action verbs when you write a PSO statement. Multiple action verbs. Because you are now trying to capture several things. What kind of action verbs can we use? Say, right from formulate, specify, conceive, design, plan, architect, build, implement, test, operate. All these are activities of engineering. Right? These are all verbs that you can make use of. And following select, analyze, retrieve, estimate, calculate. You can use a combination of these action verbs to write your statement. That's all. Now, and when you write your PSOs and POs together, there should not be any curricular gap in this. For example, if I identify a course which I cannot relate it to any of the PO or PSO, then I have not written my PSOs right. Or I have not designed my curriculum right. Either way. You take a course and say what PSO it is addressing. If I cannot answer that, either I have unnecessarily put because of some compulsion a course there, or that I have not written my PSOs right. That's all. Okay, either way. Here, and there are some common mistakes that are done. You should not use words such as etc. various. They are banned. When you write any outcome, you should not use this. Because when you say various etc., it is only clear to the person who has written it, not for the reader. What do you mean by various? So you should exhaustively enumerate all the knowledge elements in a statement. You have to, doesn't matter, but you generally write only one sentence, not multiple sentences. Those are simple rules we follow. No multiple sentences, a single sentence, and do not use the words anyhow. And also sometimes people, what they have done, they took a PO, and just put your branch mechanical engineer. Just put that word. That means it is a repetition of a PO as a PSO by just changing one word. Like example, understand modern management and construction techniques to complete the project stipulated. That is a PO level. Okay? And somebody has written, understand modern management and construction techniques. By adding the construction, it becomes civil engineering PSO. No. Okay, but that is already taken. You don't have to write that. That is PO level. Similarly, apply the knowledge of mathematics, science, engineering, fundamentals to the solution of problems in computer science and engineering. That is again, it is already PO1. So you don't create that as a PSO. That's all that means. And they should also be not written to represent electives. It is not that electives are not important. Electives are important. But the NBA accreditation process defines your PSO should only should be attained through the core courses. Okay? Core course means everybody belonging to that branch takes that course. But whereas by definition, elective is not taken by all. Same elective is not taken by all. Okay? So these are the simple rules you have to follow. Here's your favorite thing, civil engineering. We have a sample. This is written by not by me. 3 or 4 specialists in civil engineering only, both from industry and academy. Survey, map, and plan layouts for building structures and alignments for canals and roads.
Sir, one more question.
Yes, sir.
Actually, as per the review, curriculum is same from all the colleges. But every college, they are writing different PSOs. Yes.
You can, but again,
No, it will be so many PSOs. 100 colleges are there, 100 PSOs are there.
that's okay. But the whole issue is this is a problem created by ourselves because a college should be completely autonomous at any stage. That all these problems have come because you are superimposed an impossible structure. Because it satisfies number of people because there is power involved in that. I am controlling the whole world.
But the UGC has made it very clear. They are
What?
going to abolish the affiliated systems.
In future,
Future.
that is the key word. When it will happen, we don't know. People will keep on raising objections to postpone indefinitely. Okay. So here, if you look at the second one, specify, design, supervise, and test and evaluate. See, several action verbs I'm using. To evaluate foundations and superstructures for residences, public buildings, industries, one list we given. Okay, if your branch doesn't address all of them, remove it. You can slightly modify it, make it particular to you. Analyze water resources, hydrological systems to estimate safe and assured withdrawals. And specify, design, and evaluate water conveying systems, hydraulic machines, and such systems. If you don't have courses, let us say, on such systems, okay, remove them. And specify, select, and formulate environmental engineering systems. It is only limited to specifying and selection of that. So as you can see, by slightly modifying the verbs or the elements, knowledge elements, you can particularize to your own branch. Now, for ECE, specify, design, prototype, and test modern electronic systems that perform analog and digital signal processing functions. So practically, all the courses will come on the electronics side. And similarly, architect, partition, and select appropriate technologies for implementation of specified communication system. So communication is captured, but if I'm going to say I have some specialty, I add design essential elements of modern RF and wireless communication systems. You can make it possible. For example, I can also break this into two. Break the first one into two. Analog and digital, I can separate it out into two. Similarly, I can partition this into two. That is your choice, how the department feels. And this is only one way of writing for ECE. I have another sample of ECE, some other department wrote. Sample 2, specify, design, prototype, and test electronic systems that perform analog and digital signal processing functions as per user requirements using currently available electronic components. I would prefer this. Unfortunately, people follow the earlier one. They want to teach electronics with non-available components. That is how the textbooks are written, and the components don't exist in the market. But we want to teach based on that. That is meeting with electronic, right? And same, architect, partition, and select appropriate technologies for implementation, specified now we are a little more particular, wired and wireless communication systems. And the third one, uh, emphasis on a little more on power management these days. Actually, in electronics, power management has become a very dominant discipline because your electronic uh, devices have become portable and wearable components. So the way you make power supply available to those components becomes an integral part of electronics. So if you want to emphasize that, specify, design, and test power supplies for electronic systems, including battery management and power amplifiers using currently available electronic components. So if you want to be specific, you can do that. So you can differentiate also through PSOs your undergraduate. Okay. Now that is about PS4s, but we are not doing the exercise. But if you do the exercise in your department, spend some time. Don't be in a hurry. Have a half-hour meeting and let's say complete tracking PS4s. Please don't do that. You write, discuss, debate, sleep over them for a few days, and then come back and rework. So these are all iterative processes. And this is where you will have also a lot of over my dead body issues as well. So you have to go through cross all those hurdles before you come. Now we come to the our crux of it. I hope we have enough time to.
Yeah. Yeah.
So we have already mentioned course outcomes are what the student should be able to do at the end of the course. And the most important aspect of SEO, it should be observable and measurable. And well-written course outcomes will greatly help in planning instruction as well as assessment. Because we have to make all the three in alignment with one another. And we need to have a structure of an outcome statement to classify the course outcomes. Unfortunately, this is not propagated across. There is no structure that is ever presented. You can write any kind of statement, vague statement. If you write vague statement, that is only for the sake, it doesn't lead you to the assessment or instruction. So we give you a structure. Again, this structure is not something that I am inventing. It has been there for many years in kind of a school curricula and so on. People have debated, researched on this. So what is the structure? Every CO statement has four elements, four components. One is an action verb. You have performed, because all COs are cognitive activities, you are performing a cognitive activity. To represent a specific cognitive activity, you start with an action verb. Okay, that is the first part. Second part, it has certain knowledge elements. You are performing this cognitive activity on certain knowledge elements. Right? That we have already talked about. And then you may have to perform your cognitive activity under following certain conditions. That is, you have to follow this particular method of solving an equation, or you have to use this particular software. You have some conditions associated with the cognitive activity. And that is the third component. Fourth component is there are some criteria which you have to satisfy when you perform the cognitive activity. Let us say I am solving an equation. I not only have to solve an equation, but the answer should be correct within the second decimal place. I insist, let us say. So that is the fourth component, which is the criteria. So there are four possible elements in a CO statement. Okay. In that, what happens, I may not have all the time any conditions. I don't have to prescribe. There are many times there are no conditions involved, nor there are criteria involved. You solve an equation. If it's correct solution, mathematically correct, I don't have any other criteria other than being correct or not. So these two elements, condition and criteria, are optional. They are not compulsory in every single state. So all that we are saying is, start with an action verb, identify the knowledge elements, and you have a CO state. Very simple. And not simple. That is where all the problems come. And occasionally, you may have to use two action verbs. Occasionally. So don't make it a kind of a common thing. It is exceptional. That means there are two cognitive activities, both are important, with respect to the same set of knowledge elements. Okay, knowledge elements do not change, but there are two cognitive activities that are equally important. We'll give examples. For example, you draw a body plot for the given dynamic system and determine the gain and phase margins. So, drawing a body plot, I should know the entire mechanism of drawing a body plot for a given dynamic system. But I also need to identify what we call phase and gain margins for that. And that is where the two action verbs that we have, determine belongs to apply, draw belongs to your understanding. These two, that's why both activities you should master. If I only say determine the gain and phase margin from the body plot, then I need not officially know how to draw a body. That's all the issue. But you should not use two action verbs just to combine two COs into a single. One should not. That's the only exception. Okay. Now we'll show you some samples, and we also show you some non-samples. Calculate major and minor losses associated with fluid flow in piping networks. Okay. The action is calculate, which belongs to apply. Knowledge element is major and minor losses associated with fluid flow in piping networks. It is both conceptual and procedural. If I want, just for the sake of argument, I can say a condition is none here, but I can bring a condition as only in piping networks. Only I am interested in piping, I can do that. So it doesn't basically change the nature of C. Okay. Determine the dynamic unbalanced conditions of a given mechanical system of rigid objects subjected to force and acceleration. That's a C. And here action verb is determine, which is apply. And dynamic unbalanced conditions. Knowledge is both conceptual and procedural. Condition is given mechanical system of rigid objects subjected to force and acceleration. We are not talking of any type of mechanical system, but only of a particular description. One more example. Process data in Hadoop cluster using Hive and big scripts. I hope computer science people can relate to that. Action process that is applied, knowledge data and unit cluster, conceptual and procedural, and condition is using hype and fixed scripts. We are specifically using the word using. The moment you say that is a condition. Okay? And we have no criteria. If you have any issues, you can stop me here. Understand the effect of all parameters in voltage controlled oscillators through simulation using T0TR. Okay. So what is the action? Obviously, the very action verb is understand. It belongs to understand. Knowledge is effect of all parameters on voltage controlled oscillators. And condition is you have to use simulation, that too using specific software called T0TR, which the college happens to have. That's it. And we have no particular condition. So I gave you some samples, and it's not very simple to write COs. Okay, even with the course that you are thoroughly familiar with, it takes considerable effort, and it is better done as a group. I'm sure every department will have at least 2 or 3 faculty who are familiar with the same subject. So they should sit together, and only through dialogue and complete continuous discussion, then only you will be, even then it will take time. In our workshops, something like it is a day-long exercise. Even then people were not able to complete all these COs for a course. So it takes time. And what happens is there is no only way of writing COs. If I do second time exercise for my own course, I may come with slightly different set of statements. So that is also possible. Okay. How many COs should you have for a course?
Depends on the credits.
Yes, it depends on the credits. 5 is not a universal answer just because you have 5 units. Units and COs have nothing to do with one another. Units have come into existence for an administrative reason some decades back, and that has nothing to do with COs. And if anyone says that I have to write 1 CO for each unit, I consider it is stupid. Sorry to use the word, it is stupid. Nothing. There is no other word for it.
So
Okay.
is it that for autonomous college,
Uh-huh.
since we are becoming, we nowhere have the structure for units?
Don't have to have.
We does not have.
You don't have to have. Unless, as I said, our knee-jerk reaction is follow what Virgil has been doing. If you are willing to get out of that mold, you can practice it. Why do you have to unitize your syllabus? And if you go to the history of unitization, it did not serve its purpose either. Unitization was, I want to give equal importance to all elements of a course. The student should not ignore something. Exactly, you showed a way how to ignore. If I don't look at unit 4 and 5, I can still get I can pass and maybe get even first class. So you showed a way rather than ensure that everybody focuses. So if you are autonomous, throw the unitization out. Use the same, content is different. That is a different exercise. There is no need for unitization. And what happens, it depends on the way your content of the course is designed. And, and predominantly you have 3 credit courses. And for a 3 credit course, you roughly have about 6 plus or minus 1 or 7 plus or minus 1 type of COs. If you have 1 less and 1 more, doesn't matter. So there is no absolute number that you have to write 8, you have to write 7 or like that. My preference is 7 plus or 1. And officially somewhere NBA has written 6, about 6 there.
Is it 1:2?
For one credit, you have two COs. Is
No,
that the
no,
correct
no,
one?
no, 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 no.
Usually that's how the practice goes.
No, absolutely not. Neither unitization nor the direct relationship between number of credits and yeah, a 4 credit course obviously can have 1 or 2 more COs. Yeah, you can. Okay. So in this slide I wrote 6 plus or minus 2. Personally, I would prefer 7 plus or minus 1. But that is a personal preference.
So since you are talking about the units
Uh,
or chapters in a module, right now in a particular course, we may have 5 units or chapters, whatever you call them. Now, just like we have electives in a program, can we have an elective within a course? Like unit 1, 2, 3, 4 are compulsory. Then I have a 5A, 5B, 5C.
mm.
I take 5A, he takes 5B. Can we do that? Would it be a novel way of doing it?
Why?
Where
You make it complicated now.
no, I mean unit 1, 2, 3, 4 in a particular course is what everybody should learn.
Okay.
Even a core course.
Yes.
But why make all 5 units compulsory? I'm not able to get an example to illustrate what I'm saying. Just like you have electives in a program.
One thing you may not be able to have an example, but you can get into plenty of problems I can see visualize if you try to do that kind of option.
No, why not? I mean, I'm just saying in a particular course,
You get into crazy. Who will? At what time do you make the decision?
so something, I'm talking about the 80s, 70s, when I did my engineering, even electives
Mm.
were thought of a crazy idea. There were no electives in those days. They thought electives will complicate things. They are crazy idea to give electives. Everybody, we learned 5.5 years of engineering.
Yeah, I also belong to that category.
But now, I mean, the thought, I mean, we are seeing the benefit of having electives in a program. I'm saying, why not have an elective chapter in a course?
Mhm.
We can discuss that later. Just
Yeah, I can think of problems immediately, but the advantage I am not able to see immediately. What is the advantage that you will have? And you're making the student choose, right? Elective is the student's choice.
No, so it's a core course, but
Ah,
on
no.
one unit, you may focus. Let's say it's about applying what you learned in the first 4 units
Okay.
to do something. I mean, that application can be different for different students depending on their interests.
No, but does the student have a choice to go through 5 or 6 or 7?
Yeah, but it may not be classroom based, it can be online.
Okay,
Self-learning.
that is a different mechanism. But now, at some point, the student has to make a choice.
Right.
And then, on what basis will he make a choice? Does he have the knowledge? And can he change the choice that he made? Somehow he finds it difficult. No, I want to go through the
In
other
the
one.
same way, he or she makes a choice for a particular course in a program.
Yeah, but there at least that you have created as a unit. But within a course, how do you measure the performance of the student? Let's say in this course he got a grade A or B or something like that. So I'm sure when you get into the details, you get plenty of
What is
issues.
the advantage of doing this?
Just like having elective in a program. Why have electives in a program? That I focus on what I want to do.
But course is very micro, sir.
I know,
Course is very micro and it's very specific.
If you want,
It's just a thought, sir.
okay, I will tell you, I will agree with this much. You try in one course, okay? Don't make it a rule that be across in a particular department or the college. You try in one course. If the college permits you to do that, and see whether it is doable, and if you have desirable results, you can further expand it.
But operation challenges will be very high.
Yeah, that's what I said. My first reaction is the operational challenges.
But I mean, the bringing more flexibility.
But if you can, for example, I read even research papers where at a postgraduate level, you negotiate the syllabus of a course with the students who join you. That is, you decide together what kind of material you want to learn. I think it was a stupid idea, it never took off. It never worked.
One more question.
Yes, sir.
In one elective group, the subjects will be same complexity should be there, or one is more complexity, one is less complexity, and students are preferring only less complexity subjects.
No, the preference of the students you cannot control. Anybody will go for easy one. Either easy courses or what he thinks will get him a better place. That will be the basis of his choice.
Sir, or
But all groups of electives need not be of the same complexity.
No, some same group, one group, 5 subjects are there, all 5 subjects should be having the same cognitive level or different.
It doesn't have to be. It depends on the nature of the subject. Some can be descriptive, some can be conceptually very complex. No, that is not the issue. How the students prefer is their choice. That is the concept of elective. For what reason he selects, you are not controlling that. Okay?
sometimes they choose based on who is teaching the course.
Yeah, that also is possible.
A good professor or a lead professor, it also influences the choice in the Western world and IITs.
Okay. So here, and another thing with regard to outcomes, attainment of course outcomes is measured through summative assessment only. Okay? And it should be possible to determine the attainment of a CO through normally followed assessment mechanisms without needing additional things. You cannot ask the students to write another test to determine to what extent they have attained, other than what is followed for giving the awarding the grade. Okay, that you have. It is the practice of many universities to present the service of course in units that we have already addressed. There need not be any need for correspondence between number of units and number of COs. There is no anything justifiable reason. And there are some do's and don'ts and checklists that you have to use to follow. What are do's and don'ts? We say use only one action verb. And use two action verbs under exceptional conditions. And do not use words including like, such as, different, etc. etc. also should not be used. With respect to knowledge elements, enumerate all the knowledge elements. Some people say, no, sentence will become long, doesn't matter. And we have never seen a sentence which is so long that it is objectionable. There may be maximum 5 knowledge elements are likely to come. Never saw anything bigger than that. Another half sentence, another half line will come into a statement, that's all. Okay, put in effort to make the CO statement as detailed as possible and accurate. And do not make it either too abstract or too specific. If you make it too abstract, you do not understand. What is the scope of that? If it is too specific, it looks like a single problem. It is possible to commit that mistake. So, whenever you write your COs, you religiously follow this do's and don'ts, and we have a checklist. You check your statement whether you are doing or not doing something here. Does the CO begin with an action verb? It should always start with an action verb. And is the CO stated in terms of student performance? That is the most important, not the teacher performance. Like teacher, when he thinks from teacher perspective, I must make my students familiar with this, you get into that kind of language. Okay? And sometimes you also say only subject matter to be covered. You should not give a list of topics. Is the CO stated as a learning product rather than a learning process? And this is a common mistake many people without inadvertently make. You have to correct that. You talk about the process of doing something rather than what is it that you should be doing at the end. Okay, learning product, not the learning process. And then is the CO stated at the proper level of generality and relatively independent of other COs. COs should not step on each other's toes, and the reasonable level of generality, so that I can design a large number of your assessment items for that. If I can't design a large number of assessment items, all that I can do is come with 4 assessment items, then it's not a CO. If I mark the answers for the CO, I have attained my CO. Okay? And is the CO attainable? With the given resources, in the given time, I can be very ambitious about a course and write a fantastic CO. Yet it looks nice, but do I have the time available? Do I have the required resources available with me? You have to make sure. Okay? So these are the checklists that you have to apply religiously after you write your COs. Let somebody even take a look at it and then make sure that these are not valid. Okay. Now let us look at some samples written by faculty. Now assimilate the physics, characteristics and parameters of MOSFET towards its application in amplifier. Do you consider it is a good CO? It doesn't matter, you can belong to any discipline. Just look at the structure of the statement and say whether it comes
Like
to.
a person than a CEO.
Huh?
It's more like a person than a CEO.
Why do you say it's a question?
It's like
Assimilate. What do you mean by assimilate?
Understand, absorb.
Huh?
Absorb.
Uh,
Understand.
if I absorb, how do I measure whether you have absorbed or not?
So it's not measurable.
It's not measurable. That is the problem with that. It is not a measurable. Assimilate the physics only. Okay? And to what extent, what is the level of detail of physics that he has to assimilate? So it is first of all unclear and it is not an appropriate action level. Assimilate is not measurable and it is not an acceptable action level. Okay, let's look at one more. Model MOSFET as an amplifier in terms of physical parameters.
No action verb.
Model
Action.
Model is an action verb, acceptable action verb.
Except the first one, if I were to replace assimilate by explain, how do we measure explain? What if I means of a written exam?
Explain.
If I use the word explain in place of assimilate,
Yeah.
would that be okay?
To a certain extent, still for me it is not a very well
Explain,
action.
how do I measure? By means of some written
No, I
exam.
will ask him to explain. Explain the permitted action verb.
No, how do we measure? Again, the means of some internal assessments or a final exam.
So whatever exam you have, for example, a SIBO, you may measure it through internal tests as well as the general exam. Yes, all that is possible.
Even the amount of assimilation can be measured by means of a test.
Yeah, but how does the student know to what extent he should assimilate? What is the level of detail to which he has to go? The model MOSFET as an amplifier in terms of physical parameters, that part is related to the first one only, sorry, that is not a CO. We are just modifying whatever you said, remove the assimilate, and we are calling it, if I can write model MOSFET as an amplifier in terms of its physical parameters. I can reword my first CO. Okay? Now another sample, analyze and assess the performance of linear and switching regulators with their variants towards application in regulated power supply. Can you find anything wrong with that? Pardon? Yeah, one is two action verbs. And we are not very sure whether MLIM is appropriate for this kind of activity. Two action verbs is the problem. Determine the performance of linear switching regulators with their variants and used in regulated power supplies. So I read it to ensure that it's made a little more clear. Okay, that's the idea. Explain internal schematic of op-amp and define its performance parameters. Hmm? Pardon? Is it an acceptable CO?
Explain, we are not. Explain.
Explain?
We are not.
The explain
Yeah,
is
it's two
teacher
action
specific,
verbs.
but it should be student specific.
Explain is a valid action verb. We ask a question like that, explain something. That's a valid thing, except that it has two action verbs. Define and explain. Okay? There are two action verbs.
No, but that is teacher specific.
No. Two action verbs. We said we should not be using two action verbs. That's all. So instead of that, identify the performance parameters of an op-amp using internal schematic. I rewrote that my scheme. Design, build and test op-amp based analog signal processing and conditioning circuits towards various real-time applications.
More verbs.
More action.
More action.
Yeah, one is multiple action verbs and the word various. You should not use the word various. Okay? Three action verbs, use the word various. Many universities, sorry, did I? Yeah, I can give many more examples we collected over a period of time through workshops. All the errors people can commit. If you have time, I can give you more examples. Now what we want to do is, we also, now we have to link it up with the POs and PSOs. So little time, we will complete this.
What is it? Buses will post 4 o'clock. Can we extend? Take it to how many people?
No, 3:38, we will complete before 12. See, the issue is now, our goal is to do what? I should be able to measure the attainment of my outcomes, and I should be able to design good assessments. It should facilitate me to design assessment. It should also facilitate me to plan my instruction better. All the three functions we want to do. Now, towards that, we want to kind of tag, associate some issues, something with that, and then we are attaining these outcomes. We are we are attaining some of these POs and PSOs through this for each course. So I have to tag my CO. One thing is PO. Which PO is it likely to address, right? Out of the 12, is it addressing 1, 2, 3, whatever, it depends. Second one is which PSO is it addressing. If I write my PSO properly, every CO of a course will address the same PSO. Okay? Then the third one is the cognitive level. That is easy to identify because the action verb that you use will tell me what is the cognitive level. Then I will also talk about which are the knowledge categories that I am addressing. That is also possible if I write my CO properly. Knowledge elements are there, whether they are conceptual, procedural, factual, or that I can tag. Including, if you want, engineering categories of knowledge as well. And then another thing that we add, whenever we write a CO, we also have our view, a teacher's view of the importance of that, whatever concepts, whatever procedures involved in that, right? If I consider something more important or critical, then I will spend more time on that, either through giving more examples or spending more time explaining in different contexts and so on. So my view of the importance gets translated into number of sessions that I take, right? In introduction, for example, I want to give an overview of the course. I may take only two or three lectures, sometimes even one. But when I want to explain something which is core, I will take 10 sessions. So all COs do not have the same scope. And the scope of each CO is decided by the instructor. Teacher decides what is the importance he or she wants to give. Okay? So to that extent, we want to tag every CO with several elements. One is PO, PSO, the other is knowledge category, cognitive level. Second is knowledge category. And finally, number of classroom sessions that I take. It is a very rough indication of the importance that I give to the topic. That's all. It is not a precise number. Okay, and also it tells me how to plan my instruction. I have to address this CO using 8 classroom sessions. Whereas another CO, I want to only take 3, so my instruction will have to be planned to be addressed in 3 sessions. So if I am able to tag every CO with this, then I have at least described my course in terms of COs appropriately.
So is it desirable? I don't know.
What?
Many people that if there are around 6 COs, first 3 COs can be taken by one faculty and other 3 COs can be taken by another faculty. Can I also map the expertise level of the faculties and map it?
Now, if 2 faculty are giving the course, let them sit together and write. Simple. And who wants to give, what teacher wants to teach, let them decide between themselves. That's all simple. If you want 2 faculty to give, just that is a simple way of handling it. But by and large, unfortunately, this kind of practices are practiced, especially in Kerala, very much because of the faculty employment issues that are involved. A course is taught in all BA, BSc programs by 3 faculty, one course. And a person is responsible for only 1/3 of the course. He or she doesn't have to know anything about what happens in the 2/3 of the course. That's a strange situation that we have created. Because if you want to modify that, first thing they'll say people go on strike because somebody has to lose the job. Okay, we cannot address that kind of thing. Okay. We will, for tagging, I will directly go to an example. Like this. Finally, my course description will come through this. Let me explain backwards. So I write my COs. There are 7 COs. It is a 3:1:0. That is 1 tutorial hour every week. And assuming that your tutorial is not an additional lecture but tutorial, then if you look at it, there is only one PO1 that can be addressed through this kind of COs. And there is a PSO1. So that is very straightforward. Only one PO1, none of the other things fit into this. And then cognitive level, CL is cognitive level. And U means understand. We just use the short version. So illustrate the terminology of mechanisms belongs to understanding. And identify the degrees of freedom and motion characteristics of Leonard mechanisms. Understand. Then these belong to apply. And so each one, the way you've written your CO belongs to one of these three categories. As we said, most of the engineering science courses they stop at apply. Very rarely they go beyond that. And then KC is knowledge category. So first one is factual. Second one is uh, conceptual and procedural. And third one also that. The CO4, it is P, that is procedural, FTP, fundamental design principles. If I want to bring in, what do you call, Vincenti categories of knowledge. And here, draw the profile of the can for a desired follower motion. So you are talking of procedural and criteria and specifications as well. Okay. So like that you write, and then number of class sessions, they should add up to actually not 38, they should add up to 45. 45. It's easy to adjust the number of sessions to make it 45. And you will have actually 15 officially tutorial sessions. You have to have 15. And how many tutorial sessions you want to have with each particular CO in this. Okay, finally your course description will have to come in a table like this. From here, it proceeds to the actual course design. First stage in course design is to bring the course outcomes to this format. Okay, I'll just have one more sample. Fluid mechanics. There is no tutorial. It's a 4 hours. And so you are going to have 4 into 15, actually 60 lectures you need to have. And these are only 5 COs. And once again, if you are truthful, you cannot go beyond CO1. You cannot keep on ticking boxes just because something you have to tick. Okay? This is another sample. Still another sample. So you have a lab also. Lab integrated into the core field course. And then your COs will have to be accordingly integrate the lab part as well. So that is, I will not go through each one separately. But you will have criteria and specification, practical constraints, all. If you have, let's say, you have to design using this particular IC. If I have to teach like that is a practical constraint. I can't use any other device, hypothetical device I cannot use. This is the only commercial device that is available in my lab or in the market. So that becomes a practical constraint. So you again, it has to be 45 and 15 into 2 that has to become 30. That can be easily adjusted. So this is how you kind of finally describe your course according to this. Bring it to this level, and from there you can have all kinds of discussions. Now this is where we pass, and if you have questions.
Well, while giving the course outcome, knowledge is okay and other student is okay. Then we have to see the student level also.
You write accordingly.
Because no, we can slightly retune based on the students we have.
That is what you are supposed to do with the curriculum design. Yes, there is nothing like you have a curriculum irrespective of the state of the students. It doesn't have, that's why somebody wants to start with the IIT curriculum and then work towards your college, that is absolutely not right. That is what happens is they are doing disservice to your own students because again they cannot win. And you keep on watering down your assessment and everything. That's not good.
Correct.
Sir, as you said, the number of course outcomes should depend on the credits.
Yeah,
So,
number of things.
like usually the labs we ask, the labs credits is usually one or two. So, what should be the appropriate number of COs there?
Okay, for laboratory, if you can actually group the experiments depending on the nature of the experiments that you have. Let's say you divide your lab experiments into 3 groups, write 3 course outcomes. If you can divide it into 4, write 4 outcomes. As per that, you group your experiments.
Thank you, sir. It was a good 2 days interaction. I was one of the one who asked most questions, apart from Nagaraj sir and Palla sir. It was very enlightening, sir. Thank you very much. Just a note for all the participants, the quiz has been set up on the Quick Learn app. The password is today's date in the reverse order, 2024, year 2024, then the month 06, and today's date 22. There will be 10 questions, and I'm told some of them may have multiple right answers, not just one. Am I right, Vin? No? Some may have 2 right answers, some may have 3, some may have 1. Only 10 questions. Please finish them before you board the bus or get onto your bike or car. Thank you. It's enabled.
4 to 4:25.
Okay. It's only after 4:25. Huh?
Yes.
Okay. Please complete it. Thank you.
Collaborate and answer.
Okay. Thank you.
I request all the dignitaries to come over the dais and felicitate our chief guest. SVP sir, Principal sir, Yogesh sir, Maruti sir, Nagaraj sir, Prahlad sir, Ashok sir, Doreswamy sir, Kepuraj sir. Please come over to the dais, sir.
Now, just a small token of gratitude from my end. Let me thank Professor N.J. Rao sir for taking time and being here with us. It was something amazing that at this age, I think he has crossed 80, and many times even I've been also delivering certain courses at the weekends at different morning to evening, but it was too hectic for us to stand from morning to evening. Okay, I think he never even sat for few minutes. Can we all please get up and give a big round of applause, standing ovation to Professor N.J. Rao sir, please.
I request Venkat sir to come onto the dais.
Venkat, I take the privilege to call him as Venkat because since past 1 year, I think we have become so close, and he's been supporting us. Especially, I think a lot of things we have worked together, especially in customizing certain things to exclusively in the quick learn for EPCET. So humble enough, and it's great that he was with us for almost 2 days. Thank you, Venkat, for your time. We look forward to your support here continuously. It's a small token of gratitude from our end.
By the way, Venkat is also from IISc, from where Dr. Rao was associated.
So we'll be taking help of Venkat. I was telling that let us customize now the complete quick learn for our autonomous. Let us, I think, what all your COs, POs mapping, attainment, almost is OBE model is already there. We are not explored to the best of its utility because we are not autonomous. We are very structured for VTU. Now, since we are becoming autonomous, we need to explore the